Right, so for this video, what we're going to be looking at is summation notation. And what is summation? Let's look at what the directions say. It says consider the sequence S sub n equals 3n minus 4. Let's say that we want to sum up the first 10 terms in that sequence. What would that look like? What we would write, this is a summation symbol, meaning the sum of, and we would say from n equals 1 to 10. And if the sequence is supposed to be defined by 3n minus 4, we actually need to put that 3n minus 4 in parentheses to show that this entire formula is for the sequence. And what it's asking us to do is to take a sub 1 plus a sub 2 plus a sub 3 all the way up to a sub 10 and add them up. That's why it's called a summation, because we're finding the sum. So what we would do is we would first find a sub 1. So you put a 1 in here. 3 times 1 is 3. 3 minus 4 is negative 1. A sub 2, put a 2 in. 3 times 2 is 6. 6 minus 4 is 2. Put a 3 in. 9 minus 4 is 5. Put a 4 in. We get 12 minus 4 is 8. And I can keep substituting in, or I can notice that my pattern is I keep adding 3. So then I would have 11, and then 14, and then 17, and then 20. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are my 10 terms, and what I need to do is I need to add them all up. So then I can simply go to my calculator. Negative 1 plus 2 plus 5 plus 8 plus 11 plus 14 plus 17 plus 20 plus 23 plus 26, and I get, did I add something wrong? Negative 1 plus 2 plus 5 plus 8 plus 11 plus 14 plus 17. Nope, got that. It is 125. Okay? So you might be thinking, seriously, is that it? And that really is it. That's all you have to do. Right? Now, we're going to do a couple of these together because there are some things that I need to point out. So don't race ahead yet, especially don't race ahead to this one right here. Okay? All right, so let's keep going here. For this first summation here in this example, from j equals 1 to 5, j squared. So what we're going to do is we're going to add up the first 5 terms. So we're going to have 1 squared, and then we're going to have 2 squared, and 3 squared, 4 squared, and 5 squared. So we're adding 1 plus 4 plus 9 plus 16 plus 25. And you'll go ahead and put that in your calculator, and you'll get your sum. Okay, I'll let you guys do that. Let's go to this next one. All right, we're going to go from 1 to 4. So 2 times 1 is 2, plus 1 is 3. And the second term, 2 times 2, is 4 plus 1 is 5, because remember again I'm doing a sub 1 plus a sub 2, a sub 3, and a sub 4, which means I'm substituting in 1, 2, 3, and 4. When I put a 3 in, I get 6 plus 1 is 7, put a 4 in, 8 plus 1 is 9. Then I add those up, and I get my sum. Now, when we come to this example, you might be thinking, well, this is the exact same example as this one. It does look like it, but the difference is the parentheses. These parentheses tell us that the rule for the sequence is 2k plus 1. Because there is no set of parentheses here, what that means is that the rule for the sequence is simply 2k, And then at the very end, we're going to add 1. So I'm going to do a sub 1 plus a sub 2 plus a sub 3 plus a sub 4. Once I've done that, I'm going to add the number 1 to that sum. So 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. That's this sum here, and then add 1. And you will see that I get a different sum than I got there. Okay? Now, for this next one, this is multiplication, so this is still all the rule for the sequence. So I don't like that they put I in, because then that could be misconstrued. It's not the imaginary number I, it's a variable that they're using. So we're going to add up the first 3 terms, a sub 1 plus a sub 2 plus a sub 3. So when I put a 1 in here, 1 times 1 plus 1. 1 plus 1 is 2, times 1 is 2. And we always do what's in parentheses first. 2 plus 1 is 3. 3 times 2 is 6. And then 3. 3 plus 1 is 4, times 3 is 12. And I would add those up and get my sum. All right. If you want to try doing the next few on your own, you can. All right, for this next one, it tells us to start at 2 and end at 3. So we only have 2 terms. We have to do a sub 2 plus a sub 3. That's all we're being asked to add. And you might think, oh, well, should I use a G because this looks like a geometric sequence? You can. Whatever letter, just so you know that you're substituting a 2 in. So 2 minus 1 is 1. So 3/4 to the first power is just 3/4. And then you're going to take 3/4 times 4. So 4 times 3/4 is simply 3. You can see that here if you do that in the calculator. 4 times 3/4 is 0.75. We get 3. Now let's put a 3 in here. 3 minus 1 is 2. So I've got 3/4 to the second power. So I'm going to do 0.75 to the second power. And then I'm going to multiply that by 4. And I get 2.25. And then I simply add those up. Let's go to the next one. We're going to do the first 5 terms, and we are starting at 1. So we're going to be adding from a sub 1 to a sub 5. So 1 minus 1 is 0, and anything to the 0 power is 1. So that's going to be 1 over 1 plus 1 is 2. Okay. And then I have negative 1 to the 2 minus 1. 2 minus 1 is 1. And therefore I have, actually I'm wondering if it would be easier for you, rather than me just saying it all, if I actually wrote it out. Negative 1 to the 0 over 2. And then when I put a 2 in there, I have negative 1 to the first over 3. And then I have negative 1 to the second, because 3 minus 1 is 2, to the fourth, because 3 plus 1 is 4. Then I have negative 1. 4 minus 1 is 3. And then 4 plus 1 is 5. And then negative 1 to the fourth over 6. So anything to the 0 power is 1, so we just get 1/2 plus negative 1/3. When you square a negative, you get positive 1/4. When you cube a negative, you get negative 1/5. To the 4th power, it's going to be positive 1/6. And so then I'm going to go and use my calculator, and I'm going to add these up. 1/2 plus negative 1/3 plus 1/4 plus negative 1/5 plus 1/6. I'll hit enter and I will get a decimal, and then I'm going to hit math, enter, enter, and I get a fraction. And I can put that fraction answer down, or the decimal. I could put it either way, the decimal or the fraction that I got. Okay? Right. So let's look at this summation notation practice that we're going to be doing. And it's showing us that we're adding 1, and then I think that's a plus. That is supposed to be a +2, +3, plus that would be 4, 5, 6, 7, 8, all the way up till 10. And so we have to figure out which of these represents this summation. And let's see, it doesn't just go from 1 to 9, it goes all the way to 10. So I know it has to be from 1 to 10. So I know it's not this one. And it looks like this one says it starts at 2, and this one definitely starts at 1, so it's not this one. And this one looks like it's it, just from n equals 1 to 10 of n, it would be letter B. Again, these are plus signs. I'm sorry that these are hard to read. Using sigma notation, this looks like 1, 4, 9, 49. I recognize that all of these are perfect squares. And so I'm thinking, looks like I'm going to have something squared. So I'm thinking A, B, or D. I'm thinking not C. This is 1 squared, and this is 7 squared. So I'm thinking it's A. If it went from 1 to 8, it would have to also have a 64 here. And if it went from 1 to 49, I'd have to go all the way out to 49 squared, and I don't want that. Let's go to the next one. What is the value of this summation going from 1 to 4 of k cubed? So I'm going to have 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed. So I'm going to let you guys go ahead, figure out what each of these is, put that in your calculator, and get one of those answers. Okay? So going from 1 to 3 of I over I plus 2. So I'm going to have my ace of 1, my ace of 2, and my ace of 3, where I'm putting in the 1. So I'm going to have 1 over 1 plus 2. I'm going to have 2 over 2 plus 2 is 4. I'm going to have 3 over 3 plus 2 is 5. And so what I would simply do is, in my calculator, I would add those. So on my calculator, what I'm going to do is I'm going to put in 1/3 plus 2/4 I know is a half. If you want to put it in as 2/4 though, you can, just like it's written, plus 3/5. And you can give me the decimal, and then hit math, enter, enter, and get the fraction as well. Okay? I'll let you guys do that. All right, let's go to this next one. I'm going to go from k equals 2 to 6. So ace of 2 plus ace of 3 plus ace of 4 plus ace of 5 plus ace of 6. The reason I do this sometimes is sometimes I need that reminder of what I'm substituting in. So 2 squared is 4. It'll be 4 plus 2. And then I'm going to have 3 squared is 9 plus 3. And then I'm going to have 4 squared, which is 16 plus 4. 5 squared is 25 plus 5. And then 6 squared is 36